while it's uploading over here, I will QN delta T change of state.
Heat going into something can do one of two things. It can change the temperature or it can change the state. And it doesn't do both at the same time.
Yeah.
If you have solid ice at negative 10 degrees Celsius, before you can melt it, you have to bring it up to 0 degrees Celsius. So the quantity of heat that you put into a block of ice, before it can melt, you got to bring it up to the melting point. Okay, and so then once you're at 0, you put heat in. What'll happen, that should be a T, melt. Well, I'll do this. You, let's see, 0 degrees, you melt it all
200
to 0 degrees.
So now you have 10 ice, you have to add.
Okay, to bring it up to change the temperature, to go from 10 to -1, you have to put heat in it. Once you get to 0 degrees, any heat you begin starts to melt, starts to melt it. But as it will stay, here is, and here is, I should, this is a science class, right? There's solid plus liquid. Okay, and as you're melting it, all the heat goes to the melting, no change in temperature, no delta T. Okay, and then you keep putting, once it's all melted, by the way, this also stays at 0 degrees Celsius. Once it's all melted, now, liquid only. Okay, now the temperature starts going up until you get to 100 degrees Celsius. You go from 0 degrees to 100 degrees Celsius, and what you're doing is you're bringing the temperature, you're changing the temperature of the water from 0 up to, and nothing happens. And then when you get to 100 degrees, that's the, let's see, this is a melting point. And this is the boiling point. Now, once you're at 100 degrees, all the temperature is Q delta T. All the energy that goes in will boil. So now you have liquid and a gas. You've got bubbles as liquid starts to boil. Okay, and as it boils away, you get gas only.
Okay, so I gotta go through this one more time. Okay, so we start. Okay.
Here we've got our hot plate that had, it was ice only with a little bit of water in the bottom. And you've got a stirring in here, okay, with a temperature probe. The temperature probe took every 10 seconds a temperature reading. And at first, the temperature didn't go up. It went up and down because this thing was touching the side as this heats up again. So, but for all intents and purposes, when there was ice and water, the temperature didn't change until all the ice melted.
And that is where on here?
Well, let's do this. I got blue, I got green, I got orange and red, and purple.
Pearl.
So, okay, ice only, and then 0 degrees Celsius. At 0 degrees Celsius, here the heat going in is changing the temperature.
Mm-hmm.
Here, the heat going in is melting. And that's this is the first line on that thing we saw with there, when there's ice and water both, okay? Then, when all the ice is melted, temperature starts to go up.
Mm-hmm.
Okay. Okay, and here, all the heat that's going in is changing the temperature.
Mm-hmm.
Until you get to 100 degrees Celsius. At 100 degrees Celsius, you're starting to boil. And while it's boiling, you have a plateau. That temperature is not changing. Once it gets to the, once you have the presence of the gas, all the heat going in is boiling. And this goes for a long time. Okay. Until all the liquid is changed to a gas, and then you have gas only.
Yeah.
And now, and you can raise the temperature of the gas. The quantity of heat going in is changing the temperature of the gas.
Yeah.
So this is a phase diagram.
Yeah, this is what I'm familiar with. This makes this, okay, that makes it, I see how it's the same thing as that, but for some reason this is easier to look at.
And that's where I said on that cube, when it was in the ice, there was no water. It was encased in ice. And that's why I said that original temperature might have been less than 0 degrees Celsius.
Yeah. Yeah, this makes sense. What I always struggle with is when does the temperature change, when doesn't it change? And when it's only ice, you have to, if you want it to melt, you have to add in temperature, add in heat to change the temperature. Yeah.
Okay, and this is for ice.
Q delta T.
Then melt, this is the quantity of heat to melt, is the mass times the heat of fusion.
Yes, yeah. Yeah, this is like, I'm like, I know it, and then I always forget it. It's just the details, you know?
And here, this is MC delta T, and this is liquid water. This is Q boil, is the mass times the heat of vaporization.
Yeah.
And then this mass times the specific heat times the delta T, and this is steam. And they all have different specific heats.
Yeah. Yep. So ice only. You have to add heat to change the temperature there to get it to 0 degrees.
That's why do they call it the melting point?
Yeah.
That's the temperature at which it starts to melt. You got to bring everything up to that temperature before it starts to melt. So then all that heat in is just raising the temperature of the ice.
Yeah.
And then as you go along, you can, after it's up to that temperature, the ice starts to melt. While it's melting, all of the energy that's going in is breaking those bonds. Breaking the bonds between the ice, between the water molecules in the solid state is breaking those bonds. Okay, once they're all broken, now you don't have any solid, you've got a liquid. All the energy going in is make them going faster.
Yeah.
Until you get up to here, now you can't make them going any faster. Any additional energy is breaking the, what is it, the hydrogen bonds between the water molecules and giving them enough energy to break through the surface and boil.
Yeah. Yep, this makes sense.
See why I had to talk about this?
Yeah, yeah, super, super important. Okay. Boom. Let me go ahead and upload this.